pure, clean running water, something that most people take for granted. But unless something is done with the deterioration of existing water distribution systems nationwide, safe drinking water may be a thing of the past. For decades, cities have dealt with the problems of back siphonage and leakage throughout their water systems, problems that not only cause inefficiencies in the system and revenue losses, but also time-consuming and costly rehabilitation. It's estimated that leakage of treated water increases the total operating costs of treatment facilities up to 30%, costing every city in the United States millions of dollars each year to treat water. In an August 1999 article in the Washington Post, it was reported that the D.C. Water Agency has an unbilled rate of 24%, and the Washington Suburban Sanitary Commission, which is the water provider in suburban Maryland, is losing 20%, for a total amount of almost 66 million gallons of lost water per day. Combine those costs with the hundreds of millions spent on ongoing repairs and rehabilitation to the existing systems, and you can see the drastic need for a change. Water utility companies in every municipality across the country are aware that there is joint leakage, pipe failure, and serious corrosion problems within the existing piping and joint systems now in place, and budget for allowable losses of hundreds of millions of gallons of water each day. In addition to lost revenue, contamination of the drinking water causes thousands of deaths each year, and more than 1 million people contract waterborne diseases from contaminated water and bacteria that flourishes on the existing pipe walls. When pressure is lost or negative pressure is induced in a leaking system, contaminated water or sewage may be pulled into the system. Once in the existing systems, these contaminants attach to the highly corroded walls, flourish and multiply in the water distribution systems, water that is delivered to homes in the United States. A 1997 Environmental Protection Agency report to Congress states that the nation's existing water distribution system is in serious need of repair. This 3-year-old report estimates that close to $140 billion is needed to be spent on the infrastructure to meet regulations. Current estimates place that figure at more than $250 billion. Why does the industry accept the premise that significant leakage is unavoidable? What's the solution? Is a leak-free, watertight system out of the question? There's only one way to eliminate the problem of water loss and contamination, and that is to eliminate leaks in the system. Now there's a solution with all the benefits that municipalities have been searching for in a leak-free system: lower installation costs, fewer and less costly repairs, less contamination, and more flow and less water loss. The result is a decrease in costs and increased revenues. Municipalities, construction and engineering firms, and contractors are now looking to polyethylene piping systems for cost-effective results in the field. No other piping system matches the solutions offered by polyethylene.
We have over 20 river crossings in our system, and they range in size from 48-inch down to 6-inch. And we have about 8 really big river crossings down to about 24-inch. We are unaccounted for water, which we like to keep at 15% or less, was hovering around 20 to 22%. So we normally every year test our river crossings. And we did find a substantial leak in one of our 24-inch ductile iron water river crossings. We engaged the services of divers to go down, and we found a 4-inch hole as a result of corrosion that was shooting straight down into the bottom of the Canal River. And we estimated we were losing between 3 and 5 million gallons of water a day. I had a very good comfort level with polyethylene. I knew what it can do. I knew we had actually slip lined some 12-inch lines with polyethylene through some areas where we had some slip conditions where the hillsides were actually slipping. So I knew it could be done. Our biggest concern was the going down the banks and the turns that the polyethylene would have to negotiate over that 1,000-foot distance as to whether something that big of diameter could actually negotiate those turns. The actual insertion only took about 4 hours to insert. We had a little bit of trouble coming up the other bank, and that made us a little concerned, but the dozer actually was able to negotiate that final turn, and we felt a lot better when we saw that pipe coming inside that 24-inch ductile iron pipe. A new 24-inch ball and socket river crossing, including engineering and installation, would have been over $500,000. We were able to insert a 20-inch high-density polyethylene line inside the 24-inch at a cost of about $125,000.
With the volatility and explosive nature of transporting natural gas underground through pipelines, the natural gas industry went to safe and reliable polyethylene piping systems more than 40 years ago. This 40-year history of success in providing safe and reliable products for the natural gas industry has enabled the polyethylene industry to research and develop pipe and fusion technologies for the water industry that meet or exceed AWWA standards.
Carlsbad Springs Water Supply Project is a project that was undertaken just outside the city of Ottawa. It's a new kind of water system designed to service this primarily rural area located outside the urban boundary. It involved servicing about 775 homes altogether, and these homes were currently supplied with potable water through private wells. These wells ran into water quality problems. They were getting contaminated from septic systems, and so a lot of bacteria was getting into the water and thus becoming unhealthy. The trickle feed system was a type of system that we saw out in Western Canada, and this involved putting a small water storage tank inside each of the homes. And this tank, at about 100 gallons, would supply the balancing storage to people within their homes. These 775 homes were located on about 26 miles of roadway. So the costs for putting in a conventional pipe, say 6, 8, 10, 12-inch pipes in the ground would have been prohibitively expensive. In fact, our first estimates were on the order of about $35,000 per home for this type of system. The trickle feed system, by reducing the pipe size, we were able to reduce that to about an estimated $8,000 to $10,000 per home. In our research, we came across chain trenching as one installation method that doesn't disrupt the roadway too much. Directional drilling was another alternative that was looked at, as well as conventional open cut. To do the first two methods, the chain trenching and directional drilling, required a continuous length of pipe. High-density polyethylene allowed us to do this. In the case, we would just butt fuse the pieces together, leave them on the side of the road, perhaps up to even a mile long. We could continuously weld these pipes together. So what this did was, by joining these pipes, we could use the directional drilling and chain trenching for the project. And all told, we found that this 26 miles of pipe was virtually all installed with directional drilling and chain trenching. And it was the polyethylene that allowed us to do that. The biggest benefit of the butt fusion and the continuous pipe was that it allowed us to look at these different installation methods and save considerable amounts of money over a conventional open cut.
There are a variety of insertions, slip lining and relining systems on the market today using polyethylene pipe systems. With many of the water systems operating in excess of 100 psi, pipe and joint quality is a must, with bolted connections proven to be unsuccessful in assuring joint integrity. Whether you're designing a new system with polyethylene, upgrading a current system to a polyethylene main, or just trying to rehab an existing system, it is important that you're aware of its advantages over existing piping systems. Polyethylene is corrosion resistant, self-restraining, totally leak-free in a fused system, fatigue and surge resistant, easily installed and transitioned to existing systems, durable, scratch resistant, and hydraulically smooth, inert, chemically and organic growth resistant, lightweight, flexible, coilable, and impact resistant, available in a wide variety of sizes to meet specifications, meets standards published by the NSF, CSA, and all AWWA requirements. The Plastics Pipe Institute and its members have worked together to develop standard products and piping systems for the potable water market to satisfy AWWA requirements. Pressure-rated, molded, and fabricated polyethylene fittings are available in a variety of sizes and shapes to satisfy any water system design requirement. Fused polyethylene pipe is the one material that is proven to handle the pressure and still remain absolutely leak-free. Not only are these systems fully pressure-rated, but they have the advantages of a fused, leak-free system that is easy to install and requires minimal maintenance. Once the heat-fused joint is cool, it is as strong, if not stronger, than the pipe or joint itself. It also acts as a restraint to reduce pipe movement. Obviously, the more joints created in any given length of pipe resists pipe movement and will ultimately create a stronger system underground.
In Europe, the first application, I believe, was for water tubing. In the United States, it was in oil field applications. Phillips Petroleum put some polyethylene pipe in the oil fields for oil and gas gathering applications in the late 1950s. In the late 1950s, some gas companies experimented with PE pipe for service lines. Polyethylene pipe really didn't become a standard construction material until the mid-1960s, around 1965, when the polyethylene pipe and fittings were manufactured. PE solved a lot of problems in the gas industry. One of the problems they had was corrosion leaks, and polyethylene is non-corrosion. Having a full fitting system meant that you could have use of heat fusion to join pipes and have leak-free joints. Polyethylene was available in long lengths, and is flexible, so they cut down on the amount of fittings that were being used. So the gas companies found that polyethylene not only provided them a system that was sound, but it was also more economical than the systems they were using. Well, the water industry has some similar problems in that it's been reported up to 60% of the water in some cities is lost due to leakage, and the conventional materials tend to have a leakage problem, and polyethylene, with their heat fusion capabilities, can give you a leak-free system. In addition, polyethylene is well suited for horizontal drilling and for rehabilitation of existing lines to cut down on cost. Polyethylene's smoothness characteristics gives it its flow characteristics, which enable you to use a smaller diameter pipe to get the same type of flow that you were going to get from a larger diameter pipe. But you also tend to not have the buildups on the inside of the polyethylene pipe that you do on the more conventional materials.
The members of the Plastic Pipe Institute have listened to the problems that exist in the water distribution market and have developed solutions and products that are truly innovative for cities dealing with water systems and their inherent problems. Our industry's 40-year commitment to providing innovative and proven polyethylene products and piping systems to the highly volatile natural gas market and numerous other industries has earned the Plastic Pipe Institute a global leadership role. Over the last 10 years, more and more municipalities have been looking at polyethylene pipe, fittings, and fusion systems to save time and money for new installations and rehabilitation of potable water systems. Pure, clean running water is our most precious commodity. Doesn't it make sense to take the steps necessary to ensure this natural resource? If you have any questions about how the Plastics Pipe Institute and polyethylene solutions can help solve your water system problems and needs, call us today. You'll call us a partner tomorrow.